Hello my dear students, today we are in lecture number 40 of chapter 3 current electricity. My student, we have studied and completed the combination of cell as series and parallel. Today, the another combination we will study that is very important for the competition as well board examination. It is the mixed combination of cell. Okay, so we'll start today with the mixed combination of cell. Mixed combination. Okay, my student, here the student in mixed combination will use the n number of capacitor in series. Okay, n number of cell, mixed combination of cell, n number of cells in series. Each cell will be identical, having the EMF E and internal resistance smaller, and then we will arrange that all the branches having the n number of cells in parallel with m branches. Okay, here n is the identical, n is the number of series branch. This is the n, okay, of identical cell of EMF E and internal resistance R. Okay, and m will be the number of parallel branches. Okay, so how we will arrange? Look at here in the diagram. We start arranging the cell. Suppose this is the one cell and the second one, and till how much we have to arrange here? N number. Okay, it is going to n. Now this is the one branch of series. This is the E with R, E with R, and E with R. Okay, and it is how much? 1 2 3 4 5 till n. In same way we arrange another one till n number, and we have to arrange this till the number of branches it is m. Okay, internal resistance, this is all, and then we connect with a load resistance, that is the external resistance R. All the value I'm not writing here, it will be very hectic. It is the E identical cell, E the EMF, and R is the internal resistance. This is the load resistance with R. And how many branches are connected in parallel? So the 1 2 3 4 5 till m. Okay, m number of parallel branches are connected in this way. Okay, now remember student, for each series branch, what will be the EMF? The EMF will be, if there will be the two cell, then we can write 2E, but here the n cells are connected, so the net EMF E net will be N times E. Okay, and what will be the equivalent internal resistance? So the R equivalent for series branch, we are writing here, if two resistance will be connected to R, here N resistors are connected, so the total resistance will be N times R. Okay, now for the combined, that is for the parallel branch, we will find out the EMF and total resistance. So the E net, that is the E total for the entire network. Suppose if you arrange here the E all are in parallel, so the net EMF will not going to be changed, so it remains same, it is NE. Student, you can use your IQ to solve such type of question also. If in any particular arrangement, series or parallel, if one battery is flipped, one cell is flipped, okay, then what will be the EMF? If you will flip one, then the two cell will be neutralized, that is the potential will be 0 and the rest will be effective. Okay, now we are moving. So the net EMF, it is for the entire branch is, it is NE. Okay, and what will be the resistance? Here we have studied for the parallel, for the entire branch it is NE. Okay, but for parallel resistance will be how much? For parallel branch, that is the parallel network, what will be the total resistance? So the R equivalent will be either NR. So the NR divided by M, and the total resistance R total of the network will be, this all R is NR by M and this is in series, so it will be NR divided by M plus R. I hope you understand. This is the total resistance. You can also write as NR plus RM divided by M. This is the total resistance of the network. Okay, I don't think if any students have any doubt. Now we'll use the Ohm's law. Okay, using Ohm's law. Using Ohm's law, we can write the total voltage, which is NE, is equals to current flowing through the circuit and the total resistance. And what is the total resistance? Here the NR divided by M plus R. Okay, so could you find the total current through this load resistance? If it is the current I, then we can write the current. I'm writing over here. So the current, current will be I is equals to, from here we are writing, it is NE and the LCM M will be multiplied over here. So it will be N M E divided by NR plus M R. Okay, my student. So this is the current from the resistor, external resistor. So this is the mix combination. Now what type of modification you required for the competitive question? So here I am going to discuss. Now if someone asks that what will be the maximum current through this resistor, what will be the maximum current, then how we will calculate the maximum current? We have studied the maximum power reciprocity theorem and we'll use that theorem. Okay, so we are going to study here the condition for maximum current. Okay, let me write here the maximum current. What we'll use? Maximum power theorem. We'll use maximum power theorem. What this theorem actually gives the concept, this theorem tells us, okay, the external resistance, external, we have written already, resistance should be equals to the net internal resistance. Okay, net internal resistance. That is, if this is the equation 1, okay, that is, you have to write in equation 1, my dear student, NR, this is the internal resistance, it should be equals to the M times R. How we write actually the net resistance, you can see it is NR by M. This is the net internal resistance, na? It should be equals to how much? R. So we can write NR equals to M times R. I hope you understand. Or R you can write directly the NR by M, this one. Now we have to find the current. These are the values you can put, okay, this one. Now current I, we have to find the maximum current, okay. The current maximum, it is I is equals to what was the formula? NME, this one, NME divided by NR plus MR, okay, this one. Now look at here, you have to replace this MR by NR. That is, you have to write R equals to this one, but you can write this one also, na? MR equals to NR. So it will be, let me write over here, NME divided by NR plus MR can be written at the NR again. And then maximum current will be I max, it will be NME divided by twice NR. It is N cancel out. So the ME over twice R. So you can find the maximum current in terms of M, that is the number of branches which are in parallel. But you can also find the current in terms of number of branches, that is the cells in series. What you can write? So you can write I is equals to, from here directly, NME divided by MR plus MR. We can use this one, okay, we can write this as MR. So it is NME divided by twice MR, M will be cancelled out, so NE divided by 2R. If internal resistance is given, then you will write ME by 2R. If external resistance is given, then you will write in this way. Okay, my dear student. Now, I am giving you a very simple homework you have to do. Then we'll move for the next topic. There are a number of questions in my assignment also I have given. Okay, student, kindly write down your home assignment. It is a battery of 24 cell. We are having an entire battery having the 24 cell. Okay, 24 cells. I am writing the vivid data. Each cell having the EMF, it is 1.5 volt. All right, and internal resistance as 2 ohm. Remember, this is the internal resistance. It is small r, internal resistance, 2 ohm. And this is to be connected, remember, this is to be connected in order to send maximum current through what we have to send? Maximum current through an external resistance of 12 ohm. And what is this 12 ohm? Actually, external resistor. Okay, this is the complete statement of the question. Now you have to find how are they to be connected, how you will arrange. The first one. The second one, I am asking, find current in each cell. Current in each cell. And the third question I'm asking, you have to find potential across external resistance over this R. Potential across R, that is the external resistance. Okay, my dear student. So this is your homework. Try to solve this homework and you will give in a group as soon as you will solve this question. Next topic today we are going to start. It is the RC circuit under DC supply. Okay, RC circuit under DC supply. RC circuit under DC supply, that we will supply DC current to a capacitor. This is the capacitor and this is the EMF E. Okay, remember student, whenever we supply DC battery or the cell, we connect with the capacitor, this type of circuit attain a steady state. This is the very important. A steady state. What does it mean? A steady state, it means the charge established over the capacitor, and once the charge established equally on both the plates of the capacitor and the potential established here, current become steady. That is, the particular network is considered as open circuit, and circuit is considered as open circuit. Another point you can write for simplicity to solve the question in easy way. You can write, okay my dear students, that capacitor blocks DC current. The second point, which is very important, capacitor block DC current. Why it blocks, we'll study in AC chapter in very detail. Due to its frequency 0, it blocks, this capacitor blocks DC current. It means there will be no current flow through this capacitor. Actually, initially, as you if this capacitor is not charged, you will switch on, then there will be charging of capacitor, or if you having the low potential battery, then it will discharge, but after some time it attain a steady state and no current will flow through the circuit having the capacitor, and this is termed as the open circuit, which I told you. Again, I'm telling you, suppose if you are having a circuit like this one, this is the capacitor and this is the resistance, my dear student, and you connect a battery over here. The very important point, this is the capacitor, this is the resistance, and this is the battery. Now, what will be the potential across this resistor? The question is, what will be the potential across this resistor in a steady state? And the answer is, potential across this resistor in a steady state will be 0. Here the potential will be 0. It means the potential will be established over, if at this point the potential is, suppose if it is 0, then here 0, and no potential across this resistor, it means here it will be 0, and here it is E. It means about across the capacitor, the total potential will be how much? It is E. No voltage will drop across the resistor. Remember, my dear student. Okay. I can take the number of example to explain this one, but it would be better if we'll solve few questions that will enhance your concept. Okay. So the one example I'm taking over here. Suppose a capacitor, it is connected with a resistor, and another, okay, let me connect a cell over here, a cell with the internal resistance and another resistor. Let me connect with, and the values I'm giving here, the 4 microfarad resistor, it is suppose, okay, 10 ohm. Here the battery 2.5 volt, 0.5 ohm with the internal resistance, and here it is the 2 ohm. Now the question, you have to find charge on capacitor. You have to find charge on capacitor. Q will be what? If you understand very well, then you can solve this question. So pause the video and try to solve. Let me solve. Pause the video and try to solve. Okay, student. Now look at here. In a steady state, remember this question is given in a steady state. In a steady state, there will be no current across this, because this will be considered the open circuit. If it is open circuit, then there is no current over there, this resistor also. So what will happen? The total current will flow from this branch. The total current will flow from this branch, and in this branch, this total circuit you can see. Now you can find the total current easily. What is the total resistance of this network? Here the two are connected in series. Now you don't have to see this one, remember. So the 2 and 0.5, the total resistance, these two are connected in series. If it is open circuit, then you can see this is the open circuit, now it is connected, and now you can see these are connected in series. You have to assume this is open circuit, but it is connected. Okay. Now the total resistance will be how much? 2.5, and the total voltage is 2.5. So what will be the current? Try to find out for the current. It is 2.5 over the 2.5, that is the 1 ampere. Okay, now this 1 ampere is moving across over here. So the 1 ampere goes, what will be the potential across this one? 1 ampere and the 2 ohm resistor. So the potential will be how much? It is 2 times 1, that is the 2 volt. 2 volt. Across this point will be also 2 volt, because this both are in parallel, and across this one again we will have 2 volt. Now we know that here no voltage drop, so if it is 2 volt over here, 2 volt across this one also, because no voltage drop across this 10 ohm resistor, so the 2 volt over here, so the Q is equals to C into V. We know C, it is 4 microfarad and V is 2 volt, so it is 8 microcoulomb, and this is the answer. If question is asking you have to find the energy, then you can also find the energy. Okay, my dear student. Now the next question I am discussing. And then I'll give you some homework. The next question is this one. This is classwork. You will pause the video for a few seconds and you will try to solve this question. Here the 3 battery I'm connecting, 3 batteries, 3 shells, and the resistor I am giving you, here the capacitor, and here the resistor again. Okay, here the 2, 1 ohm, 5 microfarad, it is in ohm, It is an ohm and 12 volt, 6 volt and 6 volt. Okay, this is a very interesting question, my dear student. Okay, how you will solve? Try to solve by yourself if you can solve. Let me write the terminals here, the A, B, C, D, E and F. Again, in this question you have to find the charge across this capacitor of 5 ohm. Okay, pause the video and try to solve. Okay, now look at here. Let me solve. First, what we have to do? First, we have to find the equivalent resistance and total current flowing through the circuit. Now, if this particular capacitor is connected in circuit and this is considered as the open circuit, if it is open from anywhere, it means this particular battery will not provide any current in the entire circuit, remember. And now you can see there is only one branch is responsible for the current, but this battery is connected across this one, so between F and C this battery will be, but there is no effect of this battery in this branch. Now try to find out the total current. Start moving from here. If you are moving from here, current I, we are moving, we meet with the negative terminal, so minus 12. Now here with the current plus 2I plus I plus 6, and we come back to the same point, it is 0. Now you will calculate the 3I is equals to 6. So I is equals to 2 ampere. If it is 2 ampere, what will be the potential across? It was connected. Let me connect it. Okay. What will be the potential across ED? So the B across ED, it will be here the 12 volt minus this potential, because this battery will lose potential across this one. So it is 12 minus how much? It is, the current is 2 ampere and the 2 to the 4. So it is the 8 volt. And so these three are in parallel. So VFC and VAB both will be same. How much? It is 8 volt. You can find over here also. Here the 2 ampere current it is going. So the 2, 1, 2, and here the battery will sum up the current, because this one releasing the current, this is not releasing the current, this is charging. That's why the voltage will sum up. Here the 2 volt and 6 volt, 8 volt. Now you are finding VAB, it is 8 volt. Okay. Now we have to find the charge across this capacitor. So we will think very carefully. Okay. Suppose here the 0 volt. Okay, 0 here also, 0 here also. Okay. The same concept I have taught you on Cisco online class. Okay. So the 0 and 0. But here what is? We are having 8 volt. Okay. Are you sure? Yes. Now move. If it is 0, what will be the potential across here? It is 6. You can see it is 6 volt. So here the 6, but here the 8 volt. It means if it is total 8 volt and it is 6 volt, it means it will be how much? How much potential will be here? Only 2 volt. Here the 6 volt and 2 volt. So we'll have the 8 volt. It means the capacitor having the potential 2 volt. Now the charge, it is Q is equals to CV. Let me write by the black because with this fade the low visibility. Now Q equals to CV. So it is the C 2 and the C, it is 5 microfarad times V, it is 2. So the 10 microcoulomb is the answer. I hope this was very easy and easy to understand also, and this way you can solve the number of questions it is given in assignment. I think 5 to 6 questions I have added this year also in my old assignment. You can see. Now student, try to write few question. Okay, I am pausing the video to just note down the problem because we do have sufficient time. Okay, my student, look at here. In this problem, try to see carefully. 12 volt battery, 2 ohm, 2 microfarad capacitor, 4 ohm and 6 ohm resistor. You have to find charge on this capacitor. Find Q, that is the charge on capacitor. Okay, you will take snapshot. Now the next one here, R1, E1, C, E2, R2, R3 and this is R4. Okay, R4, E3. Now if E1 equals to 3E2 is equals to 2E3, the relation I'm giving you, you can find out the voltage, is equals to 6 volt, and R1 is equals to 2R4 which is equals to 6 ohm, and R3 it is equals to 2R2 which is equals to 4, and the capacitance, that is the 4 ohm, and the capacitor here the 5 microfarad. I hope you can see all the data it is written. This one. Then find I3 and Q in capacitor. You have to find charge over here and I3 if it is current over here, I3. Okay, find Q and I3. Okay, so this is the question. So these two. Okay, and then write down one more question. Let me now look at here the third question. All the C here, the 4 capacitors are connected, 1 2 3 4. Okay, and all the capacitor C, it is 3 microfarad. All right, 3 microfarad, and the 3 resistor 1 2 3, another resistors over here also, but 1 ohm, but here the 3 resistor of R, all the values are 4 ohm. Okay, and the battery is connected 10 volt. You have to find charge on each capacitor. Okay, this is your question, charge on each capacitor. Okay, so this is all about today lecture, my dear students. Thank you very much.